In this video, we're going to take a look at ionic compounds. Ionic compounds are composed of positive and negative ions so that the number of positive and negative charges are equal. All ionic formulas have two parts to them. They are a negatively charged part and a positively charged part. Sorry, I'm not going to say they are a non-metal and a metal. The non-metal is negatively charged. And a positively charged part. They are an ion. This should be an ion. The negatively charged part is called an anion, and the positively charged part is called a cation. They're held together by the electrostatic force. Example of cations, positively charged ions. Well, you look at your chart, any one of these guys over here that takes on a positive charge. Gallium, sodium, magnesium. The anions, the negatively charged, all come from this side right here. Acetatide, iodine, bromide, chloride, fluoride, these ones. Oxygen, fluorine. These are anions. In ionic compounds, electrons are stolen and not shared. Right, so we're going to look at how this works. We're going to draw a Bohr diagram to illustrate the forming of the ionic compound of sodium chloride. So a single formula unit of sodium chloride. So sodium, so we go and look at sodium. Sodium's over here. It has 11 protons. That means it's going to have 11 electrons naturally. For sodium to have 11 electrons, it's going to have 2 in the first shell. It's going to have 8 in the second shell. 1, 2, 3, 4, 5, 6, 7, 8. And it's going to have one lone guy out here in its valence shell. Notice this valence shell is hardly populated. That lone guy is easy pickings for a kidnapper. Chlorine has 17 electrons in its neutral state. 17 is a lot. So it's got 2 in the first shell. It's got 8 in the next shell. 1, 2, 3, 4, 5, 6, 7, 8. That's up to 10. And to get to 17, it's got another 7. 1, 2, 3, 4, 5, 6, 7. So 7 valence electrons. Now this guy, our sodium, has 1 valence electron. Now, what did we say that atoms want to do? They want to get to full valence shells. Well, for chlorine to get to a full valence shell, it just needs 1 more electron. Then it can have a full valence shell. For sodium to get to a full valence shell, well, it would have to get 7 more electrons to fill this up. Or if it just lost this one guy, then this would be the full valence shell here. So what happens is this electron goes over to the chlorine. So then we get sodium with 2 in the first shell, 8 in the second shell. And we get sodium, because it lost an electron, it has one more proton than electrons, right? Sodium has 11 protons, but only 10 electrons, so it's got a positive 1 charge. Now that electron that sodium used to have in the valence shell here has jumped over to the chlorine. And the chlorine now has 1, 2 in the first shell, 1, 2, 3, 4, 5, 6, 7, 8 in the second shell, and 8, 6, 7, 8. 8 in the last shell. Now this last shell could hold more, but because it's its valence shell, it only wants 8. So chlorine has a full valence shell, and because it now has 18 electrons and only 17 protons, it has a 1 minus charge. Because they have a positive and a negative charge, positive and negative charges are attracted together. These two guys will stick together. There you have it. They're now stuck together as a formula unit. And our formula unit for this is just NaCl. The common charges for things are found on the periodic table of the ions. Now, this isn't all of them. Some of these transition metals can take on many different charges that aren't listed on here, but these ones are just the common ones. Okay, so we should be able to go through a table like this and talk about how things become ionic. So oxygen, it takes on a 2 negative. Oxygen has an atomic number of 8. Right, that's this guy up here. It has a mass number of 15.999, or some places just say 16.00. Protons are 8. Electrons, because it's going to be a 2 negative ion, it's going to have 10 electrons. Right, 10 electrons, 2 more than its number of protons. And the neutrons, 16 subtract 8 is 8 neutrons. That's oxygen. Now let's look at 35. 35 is right here, bromine. Bromine, Br. And bromine is in this column. Ones in this column generally take on a 1 minus charge. If we look at our periodic table of ions, bromine here has a 1 minus charge. So it's 1 minus. And it has a mass number of 79.904, I believe. I'll just double check that. Yep, 79.904. So bromine has 35 protons. And it has 36 electrons. That's why it's got the negative 1 charge, because it's got more electrons, which are negatively charged, than protons. Neutrons, we do 80 subtract 35 to get 45 neutrons. All right, Cu, 2+, that's copper. So we look up copper. Its atomic number is 29. Its mass number is 63.546. So it's going to have 29 protons. Now, because this is a 2+, it has to have fewer electrons than protons. So it's going to have 27 electrons in its ionic form. We can't change the number of protons. We have to change the number of electrons. And for neutrons, you round this to 64. 64 minus 29 is 35. You should be able to fill in a chart like this, given an element and its ionic charge, how many protons, neutrons, and electrons it has. Protons, neutrons, and electrons. All right, so that's ionic substances. They're formed by stealing electrons so that the two chemicals get full valence shells.